Hi folks, Greg Marchand here. Welcome to yet another episode of the Virtual Instructor-Led Training Program brought to you by the Service Sales Academy. In this episode, we're going to do another technical knowledge for service advisors, and this one on the cooling system, because we're preparing to talk about selling cooling system service. So again, technical knowledge, 30,000 foot level here. The more you know, the more you're going to sell. The more you know, the more confidence you're going to have in your selling, and that's going to translate to more sales. And the more you know, the better questions you're going to ask of the technicians and of the customers, and that's going to make your shop more productive and make you more money. So that's why technical knowledge. Now, the cooling system exists for a number of things. Remember, we talked a while ago about the first law of thermodynamics back in the brakes program. The first law of thermodynamics says that energy can neither be created nor destroyed, but only change from one form to another. Well, that's what our engine does. It takes that chemical energy, the chemical energy in the gasoline or the diesel, and it turns it into heat energy to drive the pistons in the engine. Now, that burning fuel generates heat because that's what we want it to do. So the cooling system is there to help get rid of some of that heat, because unfortunately, the first law of thermodynamics and engines is not perfect. And so we end up with a whole bunch of heat. It would be great. It would be awesome if we could just take all that chemical energy, turn it into heat, and then turn that heat energy into motion energy to make the vehicle go down the road. Unfortunately, they're just not that efficient. And so we get extra heat. But here's the good news. The good news is humans want heat, right? Because if we're driving our cars around in Canada, in January, we're going to need a lot of heat to stay warm. And from an emission standpoint, engines are way more efficient when they are warm. So the cooling system is there to do all these things. It's to get rid of excess heat. It's to give us humans heat when we want heat. And it's to get that engine up to temperature as quickly as possible for the sake of emissions. It's got to circulate the coolant in order to do all this, right? Now, why do we not just use water? Well, we'll get to that. I think you'll be able to answer your own question pretty shortly here when we discuss the benefits of coolant and the attributes of coolant. The cooling system also has to be able to transfer all that extra heat to the air, whether we're going to try to get rid of it in the radiator or whether we're going to try to get rid of it and give it to the passengers in the passenger compartment to keep them warm. Either way, we've got to transfer heat to the air. And then, as I said a minute ago, the cooling system needs to warm that engine as quickly as possible for the sake of emissions. So this is the job in terms of managing the cooling system that the cooling system has to accomplish. Now, the components of the cooling system are many. And look, I'll be honest, when I sat down to write this, the cooling system as a system sounds pretty simple. But when you start thinking about all the components and what those components do, it gets really complex. So for the sake of time in this program, and because we have so many components to this system, I'm going to keep this at maybe the 60,000 foot level. So if you're a former technician watching this, yes, there are some pieces missing here, but the general idea is there, and it's enough to have a conversation with the customer, and it's enough to start the conversation with the technician. So components of the cooling system, we've got the coolant, we've got a water pump, we've got the thermostat, a radiator, a heater core, drive belts, bunch of different sensors on today's cars, hoses and pipes to move all this stuff, and then all the gaskets and seals that keep the coolant in the system. So a great way of learning the cooling system and or showing it, demonstrating it to your customers is to use Virtual Vehicle. Go to virtualvehicle.com with your user and your password if you're a TechNet shop. If you're not, you can sign up for access to it, all right, for a low subscription fee. And it's really, really worth it because as you can see in this diagram alone, they're great animations, they're great renderings of the system, and you can even put it all into motion if you want to really demonstrate to the customer what exactly the cooling system does, is, and how it operates. And you can learn something from this yourself, all right? So use this tool to better learn some of the components, to visualize what these components do, and to educate your customers on what these things do. Let's talk about the coolant first. One of those components, right? It does a whole bunch of jobs. It sounds like it does one job, cool, but it doesn't. You see, that chemistry in that coolant has a higher boiling point than water does. And when it has a higher boiling point than water, that means it can hold more heat. And if it can hold more heat, it can transfer more heat. So we can't just use water because we need it to hold a lot of heat. So we have to have this chemistry we call coolant, this chemical compound that we're going to call coolant. It also has to provide some lubrication properties for the water pump because it does have a pump in the middle of it that is spinning, and spinning things generate some heat. So we need to keep that as low as possible and keep things lubricated. So it's got a higher boiling point than water. It's got lubrication properties, and then because it's a fluid circulating amongst metal and it does contain some water, we have to use it to help prevent some corrosion. So it's got corrosion inhibitors in it. And then in the really cold climates, we have to provide some freeze protection. So it boils at a high temperature, it freezes at an extremely low temperature, it has lubrication properties, and it prevents corrosion. Oh, and then it's got to be able to give up heat real easily too. So it's got all of these jobs. Well, think about what could possibly go wrong with the coolant. As with all vehicle fluids, these chemicals wear out. They're not there forever because they're doing a job. The corrosion inhibitors alone, in order to prevent corrosion, they actually get used up. So the loss of those corrosion inhibitors and the subsequent breakdown of the lubrication properties, that's a problem, right? We lose those two things and half the job of the coolant's gone. And then, look, we could leak some out somewhere. We could have internal leaks. We could have external leaks. So it's a fluid with chemicals in it that wear out, and it can potentially leak from a bunch of places because, hey, let's face it, we stick it in this mechanical thing and drive it down the road at 65 miles an hour under all kinds of different conditions. Things go wrong. The water pump. Water pump's job is to circulate coolant. It's driven by a drive belt. Generally, can you have gear-driven ones? Yep, you can, but you won't see many of those. And then the impeller, the part, the fins, if you will, of the water pump that spin around. They can be made out of plastic, metal, or rubber. So it's usually an aluminum housing, sometimes steel, spins at a high speed, and it's made of plastic, metal, or rubber impellers to make the coolant move. If this goes wrong, if this goes bad, what's a customer going to notice? Now, I'm going to point out again that I've laid this out in terms of the complaint, the cause, and the correction. We'll come back to coolant in a little bit, but for now, let's look at these hard fixed components in terms of the complaint, cause, correction, so that you get used to using these terms when you're engaging with a customer and or engaging with a technician for the sake of communicating what's wrong, what do we need to do to fix it, and hey, how do we maybe keep this from happening in the future? So when the water pump goes bad, the customer could notice a noise, howling noise, grinding noise, rubbing noise, something like that. They may describe it as all kinds of different things. They may notice the vehicle's overheating because now all of a sudden we can't circulate coolant maybe. If it's an external leak, maybe they'll notice a drip. If it's an internal leak, maybe they'll notice a funny smell, that burning coolant smell you may be familiar with. What causes all this? There's too many causes to put in here. Could be physical damage, and physical damage comes from all kinds of things. It could be a bearing that just wore out. Now you've got that whistling noise or that little airplane noise in the engine. It could be, there's a property of coolant that I didn't mention, and that property of coolant is anti-cavitation, a fancy term, I know. But what cavitation is essentially the production of a whole bunch of bubbles due to the impeller of the water pump spinning around and mixing that coolant, forming these bubbles, forming allowing the coolant to boil off, if you will, to form these bubbles. And these bubbles act like little drills, and they'll actually destroy the water pump. There'll be physical damage. I'll show you some pictures in just a little bit. So you can have physical damage to the bearing or physical damage to the water pump itself. You can have external leaks. If it's mounted under or inside the timing cover, you could have what you might call an internal leak. I would consider it external because it's external to the engine, but you could have a leak inside the timing cover that is just going to smell like burning coolant. What do we have to do to fix it? We're going to put a new water pump in, of course. and then we've got to flush the cooling system, and we've got to replace the drive belts. And you do all that together. All right, you flush the cooling system, you get the debris out of there, you put a new water pump on there, so now we got new parts, new lubricant, new corrosion inhibitors, and then a drive belt, because you know what? Chances are it's going to need a new drive belt anyway. Then there's the thermostat, right? Thermostat, we think of it as keeping the engine warm. Well, really what it does is it keeps the engine at a consistent temperature. And with fuel-injected vehicles, that's very, very important because it all relates to fuel consumption and emissions. When that thermostat's closed, it doesn't allow coolant to circulate. I mean, will a little bit circulate? Yes, it will. There's bypass tubes and whatnot, but we're not going to get that fancy here. When the thermostat's closed, keeps the coolant in one place, allows the engine to heat up more quickly. When the thermostat opens, it allows coolant to flow to the radiator to get rid of some of that excess heat. Now, there's all kinds of fancy thermostats today, and we can actually control the thermostat to control how much coolant flows. But again, we're not going to go there. Let's keep this really, really simple. If it's closed, or the more it's closed, the more heat in the engine, the more it's open, the more coolant we get to the radiator, and the more cooling there is. Now, if things go bad, well, in today's cars, believe it or not only could you have poor heat inside the car because the engine just stays too cold, but you'll likely have a check engine light on, believe it or not. And more on that in a little bit. Or it could be stuck closed and it's overheating. And all of these could be intermittent, or it could just be constant. And the cause of that is thermostat's broken. All right, sticking open, sticking closed, sticking partly open, partly closed. Either way, it's not doing what it needs to do, most likely because of some physical condition. What do we have to do? Put a new one in it. And then flush the cooling system and replace any affected O-rings or gaskets that go along with the thermostat housing or the thermostat itself. All right, so we're going to put a whole bunch of new parts in there, and we're going to put new coolant in there. Now, remember, along with all of this, depending on what damage got caused because this component failed, you could have something as serious as a blown head gasket because the thermostat stuck shut, the engine overheated, the cylinder head and or the block expanded too much and tore the cylinder head gasket. So now it looks like we have a bad thermostat, and I did see this recently. It looks like we have a bad thermostat, but we go to fill the engine back up after the repair and it continues to overheat, or it continues to lose coolant, and then more diagnosis is needed. All right, so any one of these could create even bigger problems. The radiator, well, its primary job is to transfer heat from the coolant to the atmosphere, to really the outside air. Now, that air is coming over the fins on the radiator, either from driving it down the road at low, moderate, or high speeds, or from the cooling fans turning on. So either way, we've got to get air over the external fins of the radiator so that the coolant can transfer its heat to those fins, and those fins transfer heat to the moving air. Of course, as part of the radiator, and I chose to include it here with the radiator instead of making it a separate component, is the radiator cap. That radiator cap serves a very, very important purpose. It does two things. It keeps the pressure in the system, so it allows pressure to build in the system, which increases our boiling point. So the radiator cap actually helps to control the boiling point by controlling the pressure in the system. And then as the system increases pressure and decreases pressure, that coolant will expand and contract just like everything else that heats up and cools down. And we want to be able to push coolant out of the system if we don't have enough space for it because it's expanded too much, and that's when it gets pushed into that expansion tank. And then we want to be able to draw some back in when it cools down and the coolant contracts. We want to be able to fill the space back up with some more coolant. So that's kind of the job of the radiator cap, to allow that to happen. So it's not just the radiator that's giving up heat from the coolant, but it's the radiator cap that helps control the pressure in the system, control the boiling point, and allows escape for extra fluid and for drawing in of fluid when it needs it. The radiator, of course, has multiple passageways for the coolant. It's like a labyrinth in there, and many, many, many fins for heat transfer. Now, if things go wrong, we can have all kinds of different scenarios here with the radiator, because it's I won't say it's a super complex component, but there's more to it than what you would think. The customer might notice the vehicle's overheating. Maybe they don't have any heat because cooling fans are running too much, maybe. We could have the check engine light on again. We could have external leaks and they'll notice some coolant on their garage floor maybe, or where they've parked their car last. All kinds of things can cause what goes wrong with a radiator, but those corrosion inhibitors that wear out in the coolant, they can cause internal corrosion of the radiator, which will eventually spring a leak in that radiator. We could have deterioration of the fins. We have external corrosion that there's not a whole lot we could do about, because that's time and operating conditions. So we could have physical things that go wrong with this radiator. We could have cooling fans that don't operate, and there's a billion reasons for that we won't get into. We could have an internal blockage because maybe the coolant was never changed and it's built up all kinds of sludge in there. The corrosion inhibitors have all become neutralized, and now we have a lot of corrosion and it's just nastiness circulating the system, and so we have an internally blocked radiator. Or any number of other physical things that could go wrong. A rock through it, a hawk through it. All right, so the radiator can be damaged internally or externally. What do we have to do to fix it? You got it. Replace the radiator, flush the cooling system, replace the coolant in there, and look, if it's a cooling fan issue, we've got to diagnose and repair the cooling fan circuits. The heater core. So many parts, huh? The heater core, it's like a mini radiator, only it's inside the automobile. And its job is to give off heat in the passenger compartment. So if we don't want heat, we've got to keep coolant out of it. So we just say to the valve that controls the coolant flow through it, we shut that off and no coolant through the heater core. If we want heat in that compartment, then we open the valve and allow the hot coolant to flow through that heater core so it can give off heat to us, the passengers. What would a customer notice if the heater core goes bad? Well, they might notice no heat, or maybe not enough heat. Maybe it's not no heat, but maybe it just gets warm in here, but I want it hot. Maybe they notice gurgling noises in the system. And that's not so much of a heater core problem as that is a low coolant problem, or maybe a head gasket problem, or something indicative of something more serious. The cause of all this could be internal blockage, it could be poor valve operation, it could be an external blockage of the fins itself. Maybe a mouse climbed into that heater control box, or heater box, I should say, heater core box, and built itself a nice warm house. But it's going to take all the heat from us and not give us any in the passenger compartment. Right, so there's just a very few causes of heater cores going bad, but you know what I've left out here too is look, physical damage. You know, do they rot out and leak? Yeah, they do. They can corrode enough and start causing a leak. What do we do if there's a heater core problem? Yeah, we've got to clean it and/or replace that heater core, which is not a fun job usually. Usually that's a dashboard job that no technician likes to get into. Or we've got to diagnose and repair any valve issues that might be responsible for no coolant flowing through this heater core. Now, we're going to start running out of components here, right? Thankfully. Probably too much for you, but that's okay. Drive belts. The drive belt. Now, many pumps are driven by the timing belt. So many water pumps are driven by the timing belt. So it may have a separate accessory belt, or it may be driven by the timing belt. Now, of course, if it's driven by the timing belt, this opens up a whole nother discussion, right? Because if we have a leaky water pump or we've got a bad timing belt, they kind of go together, because all that labor to get in there, all that labor has been expended. And to once you get in there to do a timing belt, well, you might as well put an idler pulley in there, you might as well put a tension in there, you might as well put a new water pump on there, because what is it? Another half-hour labor, another hour of labor, instead of having to rip all that open again if and when the water pump goes bad. If the water pump went bad, well, you might as well put a new part in there if you're taking the timing belt off anyway. So there could be a couple of different ways the water pump is driven, but either way, it's generally a belt. And these are maintenance items. So you can have this conversation with the customer about not only does the timing belt control engine timing, but you know what, it also drives your water pump. So it actually has a really, really important job, and we kind of ought to take care of that. What the customer might notice if a drive belt goes bad, of course, noises, if it goes really bad and it actually breaks. If it's a timing belt, engine won't be running, right? If it's an accessory drive belt that's driving the water pump, then the vehicle could just be overheating. And look, they're belts. They operate in a hot environment. They operate in a not so nice environment. And so you can have deterioration over time of the belt. You can also have pulley bearing damage, so there are idler pulleys and whatnot in there, or you could have a water pump pulley going bad, a bearing in the water pump going bad, and putting stress on the belt. The belt starts to slip, and eventually it wears. To fix it, we got to put a new drive belt on there and replace whatever affected parts. Now again, if it's driven by the timing belt, that's a whole nother conversation. While we're in there, to replace the timing belt, we might as well replace the water pump as well for the little bit of extra labor and the extra expense of the pump, because hey, we know these things leak, we know these things go bad, and again, the time's already been taken to go that far. We don't want to have to take all that apart again and charge the customer again for doing that a year from now, 2 years from now. Okay, make sense? I hope so. Now, we've also got hoses, pipes, gaskets, seals. All these things either allow the fluid to circulate throughout the system, or it keeps the fluid in the system, right? And oftentimes, all these hoses and pipes are related or are at least involved in the removal and replacement of engine components. So you could do a job like an intake gasket, and the intake gasket actually seals part of the system. So the cooling system touches a lot of components in the automobile. It can even touch the transmission cooling system. So it's not a simple system. It does a very, very important job, and things go wrong with it. When these things go bad, of course, the customer's going to notice external leaks or overheating, no heating, poor heating, things like that. We've got to isolate the damage to those hoses, pipes, gaskets. We've got to figure out why we've lost engine coolant, and then we've got to fix that. So we've got to reseal the system. As part of that, you're gonna clean the system out. You're gonna fill it with new coolant, and you're gonna seal up whatever went bad. Now, there's also all these sensors. New automobiles, engineers recognize the relation of engine temperature to emissions, to fuel control, and so we've got all kinds of sensors to alert the system if something goes wrong. We monitor the cooling system for coolant flow. We monitor it just to give the driver some information, right? Temperature, warning lights. We monitor it for proper engine temperature. And if any of these things goes wrong, the diagnostic logic in the computer can recognize it, and it will turn the check engine light on. So a lot of the times what we do to prevent this, all the preventative maintenance we do, is to keep the check engine light from coming on. If these sensors go bad, and or really anything in the system goes bad, check engine light's going to come on. And there are too many causes to get into here, but it could be the sensor itself, could be the coolant, lack of coolant, could be a component failing, could be a water pump's gone bad, wiring, computer, all kinds of things. We need diagnosis first and then repair. So the cooling system, you see what I mean? When I started getting into this, I'm like, whoa, this may be too much for a 20-minute program, but I just want to give you a 60,000 foot level, what the components are, what they do, what the customer may notice, and what we got to do to take care of these customer concerns. In summary, before we get to the selling cooling system service in the next program, in summary, there's a ton of components, right? We saw that. But the coolant is absolutely the most critical component to the proper operation of all of these components. It takes care of all of these many components, from the sensors to the water pump to the thermostat to the radiator. The coolant is the key to the entire system. And that cooling system has a big responsibility. It's responsible to maintain a consistent engine temperature, to give us some heat when us humans want it, and to keep emissions in. Remember, emissions are related directly to fuel economy, to keep emissions and fuel economy right where it ought to be, where the engineers designed it to be. Go through the program again, folks. okay? Visit it, one section at a time. Go check out Virtual Vehicle for better virtual descriptions of the system. And until I see you again, keep up the awesome work and never stop learning.